Okay, now members, we are going to focus on numerators. Here, these are digits that are used in writing numbers in a given base. So you know that every base has specific numerals or digits it has to be with. All the numerals in the base are always less than the base itself. So the base can't have a numeral or a digit in the numbers which is equal or above it. It can never happen. All of them they should be below it. So you have basics, the numerals have to be 5 and below. So in groups of 10, copy and complete the table below. So they are giving you an example here. They are giving the number 16, they are giving you the base, they are giving now the numerals. That means that these 0 and 1, they are the numerals. Then they are giving you an example. So I'm going to give you 5 minutes, group yourselves in 10, then copy and complete this table. Then I'm going to correct that work in the next 7 minutes. So I'm giving you those 3 minutes. I mean those 7 minutes. Correct quickly. Okay, I think 7 minutes have elapsed and I'm going to correct from a sum of 3 groups. So this is group 4. So group 4, because this was an example in the question. So group 4, this is what they are having in the base 3. So in base 3, they are putting here a 3. Then the numerals, they are having 0, 1, 2. And then an example they are giving me 2. They are giving me 2, 1. And then here they are indicating 3. Okay, let us discuss group 4 work. So for them they are adding 0, 1, 2 as the numerals in base 3. And then they are giving 2, 1. What do we check for? All the digits here, they should be below 3. So they are having 1, 2, and 2. It doesn't mean that we have to use all of them. No, this is just an example. So yes, I think here they are right. Then I sampled the group 7. Group 7, they came and they handled base. I'm going to take now the sample for base 5. So for base 5, this is what they are having. So here they are having, they are having for base 6. So this is what they are having. They are having 6 here. Then here they are having 1, 2, 3, 4, then they are having 5. Okay, what do you think? And then the example they are giving, from here the example they are giving 4, 1, 3, 2, then they are putting 6. Okay, so that's their work here. So this is base 6, the base is 6 as you see, and then these are the numerals they are giving us 1, 2, 3, 4, 5, and then they are giving us an example as this. So I think that's this number here is in base 6. First of all, we start with the example. We check, are all these digits below 6? Of course, we can't have negatives here. So are they below 6? Yes, because we are seeing 4, 1, 3, and 2. So can you give them a tick there? Okay. You also give your tick in any tick. If you have digits below 6, you give a big tick there. And then here they are having, let us come now to their numerals. They are having 1, 2, 3, 4, and 5. Are they the only numerals? If yes, why do you think so? And if no, why do you think so? Okay, someone is saying they are missing 1 digit. Which digit is that? No, which digit is that? Okay, someone is saying that a 0 is missing. So they are telling us that this one is missing a 0. Why do you think a 0 is missing? Okay, someone said the 0 is missing because 0 is also below a 6 and it's not negative. So I think we can clap for her. So that's it, and then this group was just missing a 0 there, and then they have that thing right. So in your group, I think you are having these ones. I'm not going to complete this one now. You are going to go back and you do it in your books, and you bring that as exercise. So let me come to group 10. Group 10, they handled. Group 10, they are having 5. So here they are having 5. Here they are having 0, 1, 2, 3, 4, 5. And then the example they are giving us, they are having 1, 0, 2, 5, 1. Then here they are putting 5. Okay, let us see if we can correct or if we can critique what we have here. Is the base fine? Is the base fine for group 9? Is it fine? Okay. So the base is okay, it's base fine. What about the numerals? Are the numerals okay? Okay. Members are saying the numerals are very okay. Why are they okay? Because we can see that all of them are. Some people are saying they are okay. Is there anyone who's giving a different answer from that? You are saying a no? You are saying yes. Okay, no problem. Because the other is also saying yes. You are saying no. Why do you think they are having wrong numerals? Speak up, speak up. So someone is saying this one is the numerals are wrong because we have a 5. So what's wrong with 5 being there? Can you explain more? What's wrong with 5 being there? Okay, someone is saying this 5, we said all digits are always less than the base. So this 5 is not less than the base. So someone is claiming that this 5 is not supposed to be there and is very right. Can you give him hand clap? Okay, so this 5 is not supposed to be here because we said all digits will be less than that base. Okay, what about the example? I think this is the example. You are having a 5 and then also this is 5. So even this 5 is not supposed to be here because the 5 can't be in this 5. It can be in 6 and above. So the right figure maybe you choose now any from here. We can choose any. Yes, what can we choose? 3. Someone is saying let us choose 3. You are saying 4. 0. Any. Anyway, let me choose a 4 from as is saying. So I think it's that now all the digits are below 5. So I think that's it. So I brought the 3 groups and I think they can do this. I think now you can every complete the whole. I want this work in your books, all of you individual work. Make your own notes and then you are going to bring them to me and I look through. Okay, now let us go to converting numbers. Converting numbers, it means that now numbers can be converted from one base to another. I.e., a number can do it in more than one base. So you can write a number, the same number, but in a different base. Okay, let us see what happens. Here we are going to use the idea we saw in Abacad. But now, you have to be on Abacad. So you have to be very careful. We say this one now the base is 4, this is 6, now this is 5. We are converting now then to base 10. The first idea is converting from any base to base 10. So see these are the any bases we are talking about. 4, 6, and then 5. Okay, now method, we are going to have method 1 and method 2. Let me start with method 1 here. So I have 3, 2, 1, 4. So it's in base 4. What is it we call it 2? Now we say, because this is in 4, we say these are 1s. The first digit is always in 1s. The second is in now, because this is first in 4s. Then the third digit is in 4 4s. So it means that now we get 3. Because this one is in 4 4s, we multiply 4 and then 4. Because it's in 4 fours, when you come to this one, then you say plus. It's going to be 2, but this one is in 4s now, so it's only 1 4. Then plus. When you come, we say always the last digit is always in 1, so you have 1 times 1. And then when you put this on your calculator, I want you to get these calculators, please. So you get this value 3 times. I'm going to go slow. So me here I'm having 48. Then plus, this one is 8, then plus 1. And the answer we are getting there, so we are having 57. Now this figure is going to be in now base 10. So it means that now we can write this number 3214 as 57 in the base 10. Now we are first seeing how we convert base 10. And then there we will be very okay. So this is what we meant by a number unlimited in more than one base. So we're writing this number now in base 10. Let us come to this and see. So we have 4, 5, 4, 6. First of all, are the numerals okay? Based on this idea, I think we start the numerals are okay. Okay, let us see. Now this one is, we have 6. So this one is in 1s, this one is in 6s, and this one is in 6s. So now we get the first digit 4, then times how many 6s? Because this one is in 6s, so multiply 6 2 times. Then plus, this one is going to be 5 times. This one is in 6s, so it means that we are multiplying 6 once. Then plus, we say the last digit is always in 1s, so we get 4 times 1s. So this one will be here I'm getting, okay, here I'm getting 144 plus 30, then plus 4, which is going to total 2, 178. Now this would be in base 10. As simple as that. Then when you come to this, now we see we have in 5. So this is in base 5. So meaning this is in 1s, 5s, 5 5s, then this one is in 5 5 5s. 3 times. So it means that now this one we shall say 1 4 2 3 5 as 1 times. This is one. This one is in 5 5 5s. So we multiply 5 3. Then plus. Come to 4. Now 4 is in 5 5. So we are going over 2 times. 5 times 5. Then plus 2 is in the 5s, so we multiply on the once 2 times 5, then plus. You see 3 is in 1s, so you say 3 times 1. So can you simplify this? This one is going to give me 125, I think. Yep, 125, then plus. That will be 25 times 2. This will be 25 times 4. That is going to be 100 plus 10, then 3 times that. You get that. So you can heavily simplify. So here I'm getting 2, 3, 8, and this is going to be in base 10. I think we start now. If I write this number in base 5, the same as this in base 10, you start all our digits are there. Now, I'm posing a question in your groups. You are going to answer this question. What do you note? Can I write this 6 as something to a given power? This 6. Can I write, what do you realize here? What do you realize here? This is 4 power what? This is 4 power what? 1 can be given as 4 power what? I want that in your group work. This is 5 power what? 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 So I want you to discuss that in your groups. I want groups of 5, 5. Then you give me what power do you think we can put on this, and then we simplify. But anyway, that's how we convert to base 10. Now, we are going to see method 2. This method 2 is called repeated multiplication. We are going to get the same answer, but the approach is going to be a bit different. Here, we will be careful here. How do we turn this to base 10 now? This method now, what we do, we get this figure, we multiply with the base. Then after we add, the answer we get after multiplying with the base, we add it 2. Then the answer we get, we still multiply it with the 4. Then the answer we get after multiplying with the 4, then we add 1, or we add this last figure. Let us go through that and see. The first step we get, we are going to say now, it's the same as 3 times the base, which is 4. And the answer we get there is 12. Hope you are following. Then this 12, we get the 12, then we add the next digit, which is 2, and this will give us 14. Then this 14 we get, we multiply it with the base, which is 4. And the answer we get there is, I'm getting 56. Then the answer we get, we add 1, so we get 56 plus 1, and the answer is going to be 57. And this is in the base 10, and there we are through. So that's the second method, repeated multiplication. That's how we handle it. Okay, let me add the same number on part D. In part D, we have 4, 5, 4, 6. We get the same answer. So what we do, we get 4 now times the base. So we're getting 4 times the base, which is 6. So the answer I'm getting there is, this one is going to give me 24. Are we there? Then the answer you get, you add the next digit. So I've been having now 24 plus 5, which will give me 29. This answer you get, now we multiply with, after adding, we multiply with the base. So I'll be adding now 29 times 6, which is the base. So you see here, I'm getting now 174. Now the answer we get, you add the next digit. So we are having now 174, then plus the next digit, which is 4. And this will be giving us 178. And this will be in base 10 with this. I think you can see it's the same answer there. Right? Okay. So this method is also giving you the same answer. But you can do this in one step. I'm going to do that in the last step. So let me handle now number part C, where we have 1, 4, 2, 3, and then this is 5. What am I going to do? The same idea. You get the first digit times 5. So I'll be adding now 1 times 5, which is giving me a 5. Then the answer you get, you add the next digit. So I have now 5, now plus 4, which is going to give me 9. When you, after adding, you always multiply by the base. So 9 times the base, which is 5, here will be having 45. Then 45, you add the next base plus 2. I mean the next digit. This will give me 47. Now this one multiply with 5. 47 times 5. This will give me, I'm getting 2, 3, 5. Then this one, you add the next digit. The next digit is a 3, which will give us 2, 3, 8. And this will be now in base 10. And that will be the idea. I think this is the same answer. We are with this. So now, let us do it in one step. Let me give you here a number and we do it in just one step. Let me say 2, 3, 2, 3, 2, 3, 5, and let us call this base 6. Now, this one, the idea is 1. You be careful with the brackets I'm creating. I'm going to say, I'm going to get 2 times 6. 2 times the base. Then after the answer I'll get, I'll add 3. Then after adding the 3, in the whole, I multiply with the whole of this. I multiply with the base, which is 6. Then the answer I get, the answer after multiplying this by 6, I will just add what? When I multiply the whole of this by 6, then I will add a 5. So this one, after doing this, then we add 5, the next digit there. You're going to get the same answer. So this is going to be 12 plus 3, which will be 15 times 6. There we are getting 9 plus 5. So this will be now 90. Then plus 5, which will be 95. As simple as that. Or you can get our and use our method. Or you can say 2 times, because this is in 6's. So this is going to be in 6's. So 6 times 6. Sorry. You can say 6 times 6. Then plus. Here we have 3, but it's in 6's. So you multiply 6 once. Then plus 5 times 6. Then the answer we shall get here. This is 36 times 2, which will give us 72 plus 18. Then plus, sorry, this is in ones. This one, this 5 here is in ones. So this will be giving us 32 times 2, 72. This will be giving us 18, then plus 5. And when we add this, you see this is 80 plus this 10, that's 90 plus this, which is 95. Still in base 10. You see the same approach. I mean the same answer, a different approach. Now, here now I'm going to give you activities we are going to do in your groups. Then after, I want you to arrange and organize these notes in your books, separate books. Then you bring those books for me to look at the notes you organize yourself. I should not find notes which are identical. So I'm going to give you exercise. We are going to present it with the work after organizing this work in your book. Make your own notes. Okay. Let me give the examples here. So, activity, convert the following to base 10. Convert the following to base 10. Base 10. Using the two methods. So my number 1, I'm giving you 3, 1, 5, 7. Then 2, I'm giving you 4, 1, 1. 5. Then I'm giving you the last one as 3. I'm giving you 1, 1, 2, 1, 3. This one, let me give it to base 4. Okay, let me even make this one as 0. So, you do this now as this is now. You discuss this as a group. Then you do these last 2 as individual work. Then after, you bring your books for marking one by one. And then I want all these notes to be organized by yourself in your books. See you there. So these are the methods we had to use on that number. See you.